Let's work on this example. It says to expand and find the sum. This is saying, let me find the sum of all the terms starting at the I index 0 and ending at 3. All right, where am I going to be substituting these I values? Well, into this formula right here. All right, so the formula is going to follow like this. This is going to be equal, well, if I is 0, the first term is going to be 0 plus 2 squared. Then the next term will be 1 plus 2 squared. The next term in the sum would be 2 plus 2 squared. And the last term will be 3 plus 2 squared. If we go ahead and do this, if we do these calculations, we get 2 squared plus 3 squared plus 4 squared plus 5 squared. And you go ahead and you add them all up, and that is the value of your summation. You can finish the problem. What if this problem has instead asked for the summation from I equals 2 to 5 of I plus 3 to the third power? I don't know, something crazy like this. Well, this is equal what? Where am I starting? I'm starting with 2 and I'm gonna end at 5. Where am I going to be substituting this I indices in this I index? I don't know. Right here. All right. So let's do this. The first term in the sequence is going to be 2 plus 3 cubed. The second term in the sequence is going to be 3 plus 3 cubed. The third term in the sequence is going to be 4 plus 3 cubed. And the last term in this is going to be 5 plus 3 cubed. And that's how we stop. We know where to begin, we know where to end, we know where to substitute them. That is my index. Now in this problem, they ask us to expand the following sum, and this one is really interesting because some things did change in this problem. We are starting at k equals 1, we are ending at k equals 3. Notice that the index of summation now is the letter K. What does that mean? That means that in the formula, I'm going to substitute this 1, the 2, and the 3 only where there is a K. In this example, it's right here. Right? Notice that there's another variable in there, 1 over n, and that is what's going to give us a little bit of trouble, but no problem. I show you. All right, so let's see. Let's just follow what we know how to do. All right, let's start at k equals 1. So the first part that we do, the sum, is going to be 1 over n times 1 squared minus 1. No worries. The next term will be, well, if k is 2, then on my formula says that this is 1 over n times 2 squared minus 1. And we need to continue all the way until 3, the upper bound of summation. In the formula says that this becomes 1 over n times 3 squared minus 1. All right, and if you notice here, we cannot actually go ahead and add these things. We do have a variable here. However, they all do seem to have that in common. So we can factor this out from all of them. And now we have 1 over n times my whole summation here. All right. What was this supposed to show us? That we need to be careful. If we have different things going on here, we must be sure that we are substituting the variable where the variables should be substituted into. All right, so this was going all the way to 3. How does it look like if I ask you to find the summation from k equals 1 all the way to n of 1 over n times k squared minus 1? All right, in the first part we knew where to stop. In this second part, where do we stop and how does that look like? All right, again, notice we're substituting these values for our k. So my first term of the sequence becomes 1 over n times 1 squared minus 1. The second term of the sequence, 1 over n times 2 squared minus 1, and so on, right? 3 squared minus 1 plus blah, 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 blah. All right. What are my last terms of my sequence? Well, we know that this is going to stop when k is equal to n here. So this is equal to 1 over n. But remember, into what index are we substituting this? We're substituting into this one. So now it becomes n squared minus 1. This was not affected in any of them by that k number. But if we notice, all of them have that. All right, what is the previous term? Before my very last one, what is my previous term? Well, remember, all of them have that 1 over n. Well, we are no longer going all the way to the n number. We're going to a number before it. So that will become n minus 1. So this is n minus 1 squared minus 1. Ta-da! Do not restore.